Here we're going to introduce the notion of a variable, and a variable is going to be represented by a letter, and that letter can represent any number from a given set of numbers. If we start with variables x, y, and z representing any real number, and then suppose we combine those variables using addition, subtraction, multiplication, division, powers, and roots, then we get what we call an algebraic expression. And here are some examples. Say 2x cubed minus 3 times the square root of x plus 1/2, where x is a real number. This is an algebraic expression because it's combining this variable using powers and roots, addition, and subtraction here. And x here serves as a placeholder for any real number, so any number in the set of real numbers, or it might just be serving as a placeholder for any x in the set of rational numbers. So we pick some particular set, and the values of x could vary over that entire set. So hence the name variable. The values of x are allowed to vary. And basically x is just a placeholder for any of the numbers in the set. Here we have x squared minus 3 divided by x squared plus 3. Again, it's an algebraic expression because it's combining expressions in x which are constructed using division, subtraction, squares, etc. And here, the only thing we have to worry about in this expression is we most certainly don't want the denominator to equal 0. So we can pick x to be any real number where the denominator here is not equal to 0, but that actually never happens because there's no real number whose square, when you add 3 to it, will give you 0. If that were the case, you'd have to have x squared equals negative 3. That can't happen. So this expression is valid for x in the set of real numbers. And x here again is a placeholder. And if our underlying set is the set of real numbers, then x could take any value in that set. Here we have an expression with 3 different variables, x, y, and z. And again, it's an algebraic expression. And this is valid for any number, any real number, any real numbers, x, y, and z, so long as the square root of 2 times z minus 1 is not 0. And of course that does happen when z is 1 over the square root of 2. So this expression is valid for any real number x, any real number y, and any real number z which is not equal to 1 over the square root of 2. So for any triple of numbers from those sets, this expression is valid. A polynomial is a particular type of algebraic expression. It looks like this. It's a linear combination of powers of x, and the highest power to appear here with a non-zero coefficient is the degree of the polynomial. So here a0, a1, all the way up to an are real numbers. N is some positive integer, and if an is non-zero, then n is the highest power of x appearing in this expression, and that's the degree of n. And these ai's are called the coefficients, and the entire thing here, an minus 1 times x to the n minus 1, is a term of the polynomial, the n minus 1th term, and ak times x to the k is the kth term of this polynomial. To add polynomials, we can just combine like terms, so we can add the coefficients, and to multiply we can use the distributive law. So for example, suppose I want to add these polynomials, 2x cubed plus x plus 5 plus x to the 5 plus x cubed plus 10. Well, then I'm going to combine like terms. The highest power here is x to the 5, then plus 2x cubed plus x cubed plus x plus 10 plus 5. And now I'm going to combine these terms to get x to the 5 plus 3x cubed plus x plus 15. And now, in abstract terms, this is a polynomial of degree 5, and we have it's equal to a5 x to the 5 plus a4 x to the 4 plus a3 x cubed, let's say 2x squared plus a1x plus a0. So how does this fit the definition of the polynomial? Well, we have the constant term here is 15. We have the coefficient of x is 1. We have the x squared term doesn't exist here, so the coefficient is 0. The coefficient of x cubed is 3. The fourth term doesn't exist, so a4 is 0. And the coefficient of x to the 5 is 1. Let's use the distributive law to multiply these two polynomials. So we have x squared minus 1 times x plus 1. How do I multiply? I use the distributive law, so I multiply by x squared first. It's x squared times x plus 1 minus x plus 1. And this is x cubed plus x squared minus x minus 1. And we see the result is a degree 3 polynomial here. These are algebraic formulas that you should always keep in mind when you're calculating, either with polynomials or algebraic expressions. But a plus b times a minus b is a squared minus b squared. A plus b squared is a squared plus 2ab plus b squared. A minus b squared is a squared minus 2ab plus b squared. So the result here is almost identical, except you have a negative in the middle term. Okay, let's calculate the following. X squared minus 1 times x squared plus 1. This is of the form a minus b times a plus b. Again, you could use the distributive law, or you might see directly that this is a squared minus b squared. So it's x squared squared minus 1 squared. That's x to the 4 minus 1. The square root of x plus 1 minus 1 squared. This is a minus b squared. And this should be equal to a squared minus 2ab plus b squared. So this would be the square root of x plus 1 squared minus 2 times the square root of x plus 1 times b, which is just 1, plus b squared, which is 1. This is equal to the square root of that squared is x plus 1 minus 2 times the square root of x plus 1 plus 1, and that's equal to x minus 2 times the square root of x plus 1 plus 2. Let's try the last one. We want the square root of x plus 1 going to be squared. This is a plus b squared, so it should equal a squared plus 2ab plus b squared. And so that's the square root of x plus 1 squared plus 2 times the square root of x plus 1 times 1 plus 1. And now that's equal to x plus 1 plus 2 times the square root of x plus 1 plus 1. And that's x plus 2 times square root of x plus 1 plus 2.